Okay, so now that we know about dimensions, we can decide if matrices can multiply. In order to multiply matrices, the number of columns from the first matrix must equal the number of rows in the second matrix. Now remember, when you write matrix dimensions, you put the rows first and the columns second. So we'll be comparing the columns in the first matrix with the rows in the second matrix, which are very conveniently right beside each other. So if these two numbers right here, the columns from the first matrix and the rows from the second matrix, are the same, then the matrices multiply. And the answer are the two numbers you have left. The size of the answer are the two numbers you have left. So let's check it out. Can these matrices multiply? Here we have a 2 by 2 and a 2 by 1. So these are the same, so you can multiply. And the answer will be 2 by 1 in size. Okay, the next one, 3 rows, 3 rows, 3 columns. So 3 by 3. This one's 1 row, 3 columns. So 1 by 3. These are different, so no, cannot multiply those together. Okay. The third one, 1 row, 2 columns, so 1 by 2. 2 rows, 1 column, 2 by 1. So the columns in the first match the rows in the second, and the answer will be a 1 by 1 matrix, which means just one number. Okay, down here we have a 2 by 1. So 2 by 1. With a 2 by 2, these numbers are different, so nope, can't multiply. And with this one, 1 by 3 with a 3 by 3. So these are the same, so yes, and your answer will be a 1 by 3. Last one. 2 by 1, 1 by 2, so yes, and the answer will be a 2 by 2 matrix. Okay, so how do we get these answers? We know how to figure out what size they are, but how do we get them? Matrix multiplication is the most difficult type of matrix operation. Of the basic matrix operations anyway. It involves you multiplying an entire row by an entire column and then adding up the products. Here we see it illustrated with colored arrows and colored work with a 2 by 3 matrix multiplied by a 3 by 2 matrix. So the answer is a 2 by 2 matrix that you see over here. So what did they do? Well, they took to get the first number, to get that 44 there, that number is in the row 1, column 1 position. And so they took the entire row 1 of the first matrix and the entire column 1 of the second matrix, and they multiplied those 3 pairs of numbers together, like you see here. They did the 4 times the 3, then they went to the middle of both, 2 times 2, and then they went to the last of both, 4 times 7, so they got 12 and 4 and 28, and they added 12 and 4 and 28 together and got 44. Then, here that you see in black, they needed the number that's in row 1 with column 2. So they multiplied the numbers in row 1 with the numbers in column 2, as you can see with the black arrows there. So they paired up the first numbers, 4 and 5, the second numbers, 2 and 8, and the third numbers, 4 and 9. And you can see that work right here. They added up those three answers, 20 plus 16 plus 36, and they got themselves 72. Then they did it again. They needed the numbers on the bottom. So, 37. That 37 you can see with the green arrows. That number is in row 2, column 1. So they multiplied the three numbers in row 2 times the three numbers in column 1. So you'll see here they did the 8 and the 3, the 3 and the 2, and the 1 and the 7. Added up those three answers and got 37. 37 is that row 2, column 1 number. Now let's clean that up for the final one. The last one they needed was this 73 here in purple. That's row 2, column 2 position. So they multiplied row 2 with column 2. Oop, they have the wrong color there. They used dark red instead of purple to get these three numbers here. 8 times 5 is 40. 3 times 8 is 24. 1 times 9 is 9. They add those all up, they get 73. They put 73 in row 2, column 1. All right, so let's try it out. Some getting used to. All right, so is it possible? So this is a 2 by 2 and a 2 by 1. So absolutely it is possible, and the answer should be a 1 by 2. So what does a 1 by 2 look like? A 1 by 2, a 2 by 1. 2 by 1 means we'll have 2 rows with 1 column. So we're going to have 2 numbers. I'll put blanks there so we can fill in the blanks. All right, so to get that, the first one is in row 1, column 1. So you have to multiply all of row 1 with all of column 1. Okay, so first numbers together, we got to do 2 times 9, which is 18. And then negative 4 times 5, so negative 20. And we add those up, and we get negative 2. Okay, I can erase that slot now that I have it there. Whoops, erased too much. Okay. So then I need the bottom row. So row 2, column 1. So I have to multiply all of row 2 by all of column 1. First number with first number, 0 times 9 is 0. 9 times 5 is 45. Add those answers up. That answer is what we put in the matrix, so 45. Have to erase that if I can. There we go. So there's our first matrix multiplication problem. Okay, now here's an interesting little problem. If we do the one underneath, notice these are the two same matrices, but what if they're changed the orders? Now it's a 2 by 1 multiply with a 2 by 2. These numbers are different now, so now we can't even multiply. That's the first time in our lives we've seen a multiplication problem where the order matters. In matrices, it matters which matrix is first and which matrix is second. Sometimes it works, sometimes it doesn't. All right, let's go back up here to the top. Let's try this 10 times 10 and 12 matrix here. So this is a 1 by 2 and 3 and negative 2, that's a 2 by 1. So what will work, and our answer is a 1 by 1. So we just need one spot for a number. So we need to multiply row 1 and column 1 together. all of row 1, so this, times all of column 1, which is that. So first number is 10 times 3, so 30. And then the second number is 12 times negative 2, so negative 24. So 30 minus 24, that one and only number in our matrix, is 6. All right, so let's try one more. If we have a 1 by 3 and a 3 by 3, the matrix will multiply and the answer will be a 1 by 3. May not have enough space to write that. Let's see how big it is. Let me sneak this back to make it a little more spacious. There we go. All right, so we have to multiply all of row 1 by all of column 1. So 0 with 2 makes 0. 2 times 1/2 makes 1. 5 times negative 4 makes negative 20. So 0 plus 1 minus 20, so negative 19. That looks like a 14. There we go. Alrighty. Now we need all of row 1 times all of column 2. 0 times negative 9 is 0. 2 times negative 6 is negative 12. 5 times negative 2 is negative 10. So negative 22. Oops, better be a small number or it's not going to fit. Okay, last one, we need row 1 with column 3 for the third and final space. 0 times 8 is 0. 2 times 0 is 0. 5 times 8 is 40. So 40 is our last number, if it'll sneak in here on the edge. Alrighty, so our 1 by 3 matrix contains negative 19, negative 22, and 40. All right. And one more review slide here at the end. Sometimes with matrices, it's easy to just give them a name, like matrix A or matrix B or matrix C, and then tell you a math problem involving the name of the matrix instead of writing the matrix out. So for example, something here like A plus 2B would be asking us to fill those matrices in ourselves. Here's matrix A, and they want us to multiply matrix B by 2 values, and then add those results together. So same as with regular numbers, you have to accomplish multiplying before you add. So we have to multiply by 2 before we add our matrices. So negative 12, 0, 1, and 6 gets added with negative 4, 5, 6, and 8. Corresponding matrices or elements add, so a 2 by 2 matrix can add a 2 by 2 matrix. We'll get negative 16. 5 plus 0 stays 5. 6 plus 1 turns into 7. 8 plus 6 equals 14. Okay. Of course, this can be done with any operation, subtraction or multiplying. Remember to check dimensions before you multiply, because not the rows and the columns must match. Before adding the columns of the first matrix must match the rows of the second matrix. When you need to add or subtract, remember the dimensions have to be identical.